All right, today, guys, what we're going to do is we're going to talk about line of best fit and scatter plots. A couple of things that I want to point out first of all. We're going to remember slope dude, right? So scatter plots are a lot like, well, finding the line of best fit and deciphering scatter plot is a lot like finding the slope of a line visually. All right, so we're going to start with, remember, slope dude went up the mountain, down the mountain, and then he went horizontal. Oops, and then he went horizontal. But we're also going to have a fourth type, and I'm just going to put that in a box over here. All right, so it's important to know that a scatter plot is going to be a bunch of random points. And when we draw this line of best fit, it's going to be in the middle of these points. Some of the points might actually be on the line, some might not. All right, so it's just going to be a bunch of these random, essentially data points, right? Well, like I said, there's going to be 4 different cases. I should have done this beforehand. All right, and what we're going to notice is that, so our black lines are going to those are going to be our line of best fit. And all of these red dots are going to be our points. All right, so this is going to be 1, 2, like I said, we have 4. So if the data, or these red points, seem like they're going upwards, right? Like from left to right, they're going up. Just like with slope, that's going to be a positive, right? A positive relationship. And you can see, just like with slope dude, we're coming in from the left, we hit our line, or we hit our data, and it starts taking us up. All right, similarly, if we come in from the left towards the right and we hit our line or our data, and it starts taking us down, that's going to be negative. That's going to be a negative relation. All right, now this would normally be 0, right? If we just had a horizontal line, the slope would be 0. But what this is going to say, what this is going to tell us, what the data, sorry, is going to tell us, is that this is actually and I forgot the word again, this is actually going to be a constant relationship, a constant relationship. So we will have a constant relationship. Now, when you have points data like this on a graph and it's just points all over the place, there will be no relationship. All right, so a couple of definitions. I'm going to go through these definitions super quick because you guys can screen shoot and pause. So scatter plots are similar to line graphs in that each graph uses the horizontal x-axis, the vertical y, to plot data points. Scatter plots are most often used to show correlations or relationships among data. Scatter plot shows relationships between 2 sets of data. Correlation, the relationship between 2 variables. Line of best fit is a line that best represents the data on a scatter plot. Positive correlation is that the data displayed on the graph resembles a line rising from left to right. Negative correlation, data displayed on the graph resembles a line falling from left to right. And no correlation, the data displayed on the graph neither resembles a line rising nor falling from left to right. Also, feel free to fast forward through this. You know, you guys can always just pause and check them out on your own. I'm going to skip that because this has all the information on it. So what we can see here is with correlation for scatter plots, correlation as one data set increases, the other decreases, right? So for a positive correlation, we have both data sets increase together. That means that our x-axis and our y-axis both are increasing, creating this positive line. You'll notice here that we have a strong correlation because all those points are close knit together versus a weak where they're spread out a little bit more, but they're still moving in this upward direction. No correlation as one data set increases, the other decreases. No correlation as one data set increases, the other decreases. Disregard that. Disregard that. No correlation. You really can't tell anything here, you know? There's not much, these are just random points. This is just a bunch of random data. It doesn't have any rhyme or reason. All right, and then correlation for a negative correlation, as one data set increases, the other decreases. All right, so like I said, we're going to ignore this definition in the middle. So negative, again, from left to right, we can see that this is coming downwards. And we can see that the first one's weak because the points are spread out a little bit. And the second one is significantly stronger because the points are more close knit together. All right, so let's just hop into a couple of problems real quick. So I noticed that which of these answer choices best describes the data on the scatter plot? Well, there's no way I can draw a line, vertically, or not vertically, I'm sorry, in a positive direction with a positive slope or with a negative slope, or even with a horizontal slope of 0, right? These points are just all over the place. So they're not going to have any relation, no relation. All right, another thing with scatter plots is we're going to spend a little bit of time going backwards, actually. This is very similar to what you had on another test earlier in the year, where you're just pretty much plotting points. All right, so if I want to plot this first point, I start from 0, 0. That's a cool thing about scatter plots is we're really just messing around in the first quadrant. So 0, 0 is in the corner here. So remember our rule, we're going to walk to the elevator and then take the elevator, right? Because we're going to go horizontal because that's our X. And then we're going to go vertical because that's our Y. All right, so we're going to go, maybe I should leave that there. All right, so we're going to go 1 over. We're going to chill here for a second, ding, wait for the elevator, and then we go up 1. So this point is actually 1, 1. Well, when I look at my choices, I see that I have a 1, 1 here, a 1, 1 for B, a 6, 1 for C, so we know C's out, and a 1, 1 for D. All right, so I'm like a really good test taker. So I'm going to go ahead and skip the second point. I'm going to skip this point because I know that it's the same for A, B, and D. So I know that's not going to help me eliminate choices. I'm also going to skip the third point because that's not going to help me because it's the same again for A, B, and D. So I'm going to jump over here to our fifth point. All right, and I'm going to notice that I'm going to come 1, 2, 3, 4, 5, and I'm going to chill here for a second, and then I'm going to take the elevator up. 2, 3, and you notice that this point's in between 3 and 4, so we're going to call that 3.5. So my X, my horizontal is 5, my vertical, or my Y, my vertical is 3.5. So it looks good for A, right? We've got 5 and 3.5. B is not looking good, and D is a good answer. And then last, I just need to check one more point. And it looks like if I do the next point, that should do it for me. So I come 1, 2, 3, 4, 5, 6. I chill. Now wait for the elevator to bring me up. And this point is going to be 6, 3, which is good for A, and not good for D. So our correct answer would be A. I would like to point out that you guys will see these types of problems on the test, right? So which statement best describes data from the scatter plot? So when you're going to get into problems like these, you really have to extrapolate as much data from the question, the graph, everything that they give you. Like you need to look in at the x-axis here, what it's called, the y-axis, what it's called. Like you really have to get into the problem. Like these aren't difficult problems. They just have to really be, you have to be thoughtful, right? So let's just look. First of all, we know that this is a positive correlation, right? A positive relationship because our line of best fit when we come left to right starts going upwards. So we know the slope is positive. So let's see. So we know that this is a positive relationship. So let's see. There is no relationship between seeds planted and the plants growing. Well, A's out. There's a positive relationship between seeds planted and the plants growing. So I'm really liking B right now, but let's go ahead and just finish them all off. There's a constant relationship, negative, or no, and there is a negative relationship, no. Right, so we were able to tell that just by looking at the line of best fit. All right, kind of just to drill this home with you guys, remember that if all of our points tend to look like they are going in a positive slope, then we're going to get a positive relationship. Oops. Okay. If our points just kind of are just all over the place and we don't have the ability to draw any kind of line of best fit, right? There's no line of best fit that I can draw here. That's going to give us no relationship. And last but not least, we have going from left to right, our line of best fit is going to give us a negative relationship. Something I'd like to point out real quick with these, actually I'll do it on the next one. So sorry about that. All right, so the following scatter plot shows the distance of a long jump in relationship to the length of running start time. Which statement best describes the relationship in a scatter plot? So what I like to do is if this was paper, right, I had a pencil with me, I'd go ahead and draw my line of best fit. Now, I know that some of you are going to be like, look at all these points way over here that kind of just mess it up. Well, when you're doing scatter plots, you really want to go by the rule of the majority, like the majority rules. So when I draw my line of best fit, I'm going to try and include as many of these points as possible. Right, and you'll notice that I have roughly the same amount of points completely on this side of the line, above it, right, above it, and about the same below it. I'm not including points on the actual line. All right, so now I'm just going to go ahead and start reading my questions, or my answer choices. So as the length of the running start decreases, all right, this is a red flag right here. My running start is my x-axis. In scatter plots, your x-axis never decreases. So right away, A's out. As the length of the running start increases, this is a good start, the distance of the long jump decreases. We remember from our definitions that for a positive slope or a positive relationship, that both the x and the y-axis increase. So our length of running start increases and our distance of long jump increases. So because of this decrease for long jump, we know it's not going to be B. As the length of the running start increases, distance of the long jump increases. That's what we're looking for. So our answer is C, but let's check D just in case. There is no relationship between the length of the running start and the distance of long jump. And you can tell by this line that there certainly is. Another thing to think about is, since scatter plots tend to use realistic data, there's kind of like a common sense rule. And if you just think about it, like if you were going to go try and jump, right? If you're going to jump as far as you could and you're just standing there and you jump forward, you're not going to be able to jump as far as you were if you were to take a step or two. And then if you took 10 steps, you probably get more, be able to jump a little bit further. So there is a rule of common sense here, like real life thinking. All right, which shows a correct representation of the line of best fit. And here's where I want to talk to you guys. So when you see a picture like this, I know a lot of you guys are probably like, oh, it's C, done, move on, cool, move on, fast forward. But if not, think about, we're going to count how many points are above this line. So I have 1 and 2. Well, how many points are below this line? Way more than 2. There's like, I don't know, I'm not counting them all. I don't have time to count them all. I just know that it's a lot more than 2. So it's not A. Again, look at this line. How many points are below it? 1, 2, 3. How many points are above it? A lot more than 3. So it's not going to be B. C, if you were to count these points, I can guarantee you that it's going to be roughly close. It might be off by 3 or 4, but it's going to be close. So C is our answer. D, you can notice that below this line, there are no points, and above this line, there are a lot. So D is not a good answer. You want to have, when you're drawing your line of best fit, for the most part, you want to have about equal amount of points on either side of the line. All right, last but not least, back to really thinking about the question. So in the scatter plot, each dot represents one student who participated in the 50-meter race. Vicky won the race. According to the scatter plot, how old is Vicky? So we need to look at our x-axis, which is age, our y-axis, which is time, and we got to think. Well, if I'm in a race and I win, right? I win the race. That means that I ran the race in the fastest time, and my fastest time is going to be the shortest one, right? So I'm not whoever ran this race in 14 seconds or 13 or 12 definitely didn't win, right? It's going to be somewhere down here in this 9 or 10. So I'm going to look at 9 because I can look over and I see that there's a couple of points here. And when I look over, I see 2 points on 9, but I see 1 point where somebody even ran the race faster in under 9 seconds. In under 9 seconds. So that's going to be who won the race. All right. And you can see by our x-axis that her age is 14. So our answer is C. So I just want to say good job today for everybody. The Kahoots were really good. This stuff we're going to learn about box plots next week, and then we have a test on Friday, and we are so close to winter break. I know I could use those 12 days just as much as you could. So let's just have a good week next week. Ace this test coming up next week, and yeah, if you have any questions, shoot me an email.